All right, so I'm going to lecture a bit on section 2.4. The first sheet of paper, or actually the first three sheet of papers that you're going to see this morning, or whenever you see this, aren't in my printout. These are just something I typed up that I was going to lecture on. You don't need to copy this down. When we get into solving the problems, the stuff that was important on these first few sheets of paper, I'll make a deal of, and then it'll be important to write down. But if you just kind of read through this or listen to me talk about this, it may help as we go through the section. But if you're crunched for time and don't want to spend forever doing this section, you can probably save yourself a few minutes and not suffer too terribly bad if you jump to the page in the video probably about 10 minutes up where I actually start doing the problems. But this little precursor is just to aid in your understanding. Not doing any algebra, I'm just explaining the topics. Not sure how this lecture is or isn't going to go today. I hadn't been drinking soda and didn't have the motivation to do this lecture today. And but I need to keep on. I have a whole calendar that I'm trying to stick to so I can finish these lectures before the summer ends. Anyways, I got two sodas for $2.50 at Circle K this morning, and it's 11:30 and I drank them both, so I feel wired. So hopefully that doesn't make bad things happen in terms of my lecture. So I'll go through this first page. The big thing in this first page is that we're getting words that you may or may not have heard, and even if you've heard them, you might not understand what they mean in terms of the context of an algebra class and how we're going to use them. And the words varies directly or is directly proportional to are going to be used interchangeably. So if I immediately, in this section, if I see the word directly, kind of regardless of what words are before it or after it, I'm going to consider those equivalent mathematical statements, varies directly or is directly proportional. We'll use those interchangeably. They'll have the same meaning. From a non-algebra perspective, we can say that two things or two items vary directly is as one of the items increases, so does the other. For example, and then I wrote an example here that is supposed to help you understand how these words might be used in a non-algebra setting that's appropriate. So my ability to play a song on my guitar varies directly as the amount of time that I practice, meaning my ability goes up as the amount of time that I practice goes up. This might not be so true because sometimes my ability doesn't matter. I can practice forever and I still suck. But anyways, if two items are theoretically going in the same direction, as one goes up, so does the other, those items vary directly to each other. So the more time I practice, the better my ability gets. When we actually get into the section and do the problems, we'll be solving word problems. This is a section of almost exclusively word problems, and in about a third of the word problems, we'll see the word directly, either preceded by varies directly or is directly proportional. And when I see those words in a math problem, to make the math problem something I can handle, I'm going to rewrite the problem with words that I understand. And if I see the word varies directly or is directly proportional to, I'm going to scratch those words out, or I'm going to rewrite the problem, and I'm going to change that little grouping of words to is some number multiplied by. So from an algebra perspective, the word varies directly or the word is directly proportional to can be replaced by is some number multiplied by. This is the most important thing on this sheet. That's why I try to write it bigger and bold it. When we get into the homework itself, when I see varies directly or is directly proportional to in the context of an algebra word problem, I can cross that word out, change it to is some number multiplied by, and the resulting statement will have the same meaning as the initial problem. So that's the first of three vocabulary words I consider the varies directly and is directly proportional to as the same vocabulary word, and although they're would look different. The word directly is the key portion of that. The next words that we might see that are different than directly, but they work together, are varies inversely and is inversely proportional to. You'll see the word that they have in common is inversely, and I'll use those interchangeably. So I might just, in my word problems, I could use the word varies inversely, or I could use the word is inversely proportional to. Those will have exactly the same meaning. The word inversely is the link between the two, and I'll use these little groups of words interchangeably. And then specifically, just to give you some vague idea of what inversely means, we say that two items or things varies inversely as if one thing increases, the other decreases. So, and then I wrote this example that someone's grade on a test varies inversely as the amount of alcohol you consume, meaning as one goes up, the other goes down. If the less alcohol you consume, the higher your grade goes. The more alcohol you consume, the lower your grade goes. So they go in opposite directions. Again, this is theoretically, I don't know, maybe for you, maybe that's not a true statement. Maybe that's a varies directly. The more you drink, the better you do. But in general, it would probably be safe to say that these items varies inversely. As one goes up, the other goes down. There's no algebra here. This is just to give you a flavor or a feel for what the word varies inversely, how we can use it properly. When we get into the section, we'll be solving word problems. Some of the word problems will have the word varies inversely or is inversely proportional to. And when I see those words in a word problem, those are going to make it hard for me to solve. I'm going to replace the words varies inversely or is inversely proportional to. When I see those in the word problem, I'm going to replace those with is some number divided by. So when we get into the word problems and I see the word varies inversely or is inversely proportional to, I'm going to rewrite the problem, or I'm going to scratch those words out, or think is some number divided by. Again, this little blacked out thing here that I squared at the bottom of this page, this is the most important thing in terms of if this is all we took away from this page, this is the only thing that you really need to be aware of when we get into the homework itself. And then the last page that isn't part of your notes, it has a new set of words that will work together and have the same meaning. That doesn't look spelled so well, but oh well. The words varies jointly, or is jointly proportional, or is jointly proportional to. I'll use those two groups of words interchangeably. The link between these is the poorly spelled jointly and that jointly. And for jointly, I need three items varying. And basically it says if two of the items increase, so does the other. So jointly is similar to directly because it's directly, if one item goes up, the other goes up. Jointly is like directly, but I need two items to go up to cause the third item to go up. And I wrote an example. So my weight varies jointly as the number of times I eat fast food and have dessert in a week. So the more times, if I eat a lot of fast food and I'll eat a lot of desserts, my weight's going to go in this. And the more of those I eat, the more my weight goes. And similarly, the less fast food I eat and the less times I have dessert, the lower my weight might be. So these are two items affecting the other. So my weight is affected by both my fast food and the dessert, and that makes it a varies jointly. It's still going in the same direction. Both varies jointly and varies directly. When we get into the algebra of them, are multiplication problems. Varies inversely is a division problem. So then, again, I wrote this little blurb at the bottom. Specifically, we're going to solve word problems that have the words varies jointly or is jointly proportional to. And when I see those words from a mathematical perspective, they can be replaced. And they can be replaced by the words is some number multiplied by two quantities. So varies jointly. When I get into the word problems, I'm going to replace the word varies jointly or is jointly proportional with the words is some number multiplied by two quantities. So that's the warm-up. There's three kinds of variation. There's direct and joint which are variations that involve multiplication. Multiplication. And there's inverse variation that relates to division. This is the first section of word problems that we're doing this semester. I think I will do most all the even and odd word problems, just because word problems generally will slow students down a little bit, and I want to have you see, maximum problems worked out. It would be the best use of your time if, where you're going through the lecture, as I do one problem, it would be nice if you pause the video and did the following problem, because eventually I think I'm going to do every problem in this section. They go kind of fast, and just watching me do problems, although it's good, doing the problems yourself is better. So the first 8 problems in this section have the instructions: write a variation model, use k as the constant of variation, and that might not mean anything to you. What I could have written, it wouldn't have been as mathematically elegant, but it might have made a better sense, you might understand it better. I might say, I could have said, write an equation that has the same meaning as the words. And then I'll say, and use k for the new letter, because I'm going to have to introduce a letter into these problems. And I use x sometimes, so I can't use x as my new letter. So very specifically, I'm going to take this sentence and I'm going to write an equation that has the same meaning as the sentence. And if I have to bring in another letter into the problem, I'm going to use k for the letter. So if I'm introducing a letter that's not in the problem to represent some quantity, I'm going to use k. So first thing I did is I looked at the statement. I want to translate those words into symbols or an equation. And because I know the word varies directly has the meaning as equals some number times, I can take the initial statement and I can rewrite it. And that's what I'm going to do for each of the first 8 problems. I'm going to take the words that I have a hard time making a statement with and replace them with words that will help me. So in this problem, I changed the word varies directly or varies directly as to equal some number times, because varies directly is a multiplication. And so this transformation right here is supposed to help you be able to answer this question, to create an equation that represents the statement. And I see 2 letters given. I see the letter W as a letter that's given. I see the letter X that's given. And for the sum number, that's the extra number I need to enter into the problem. I'm going to put a K. So the equation I'm going to get, the letter W, I'm going to leave as the letter W. The word equals that I inserted that the initial problem didn't have, I'm going to write with an equal sign. For the sum number, I'm going to write the letter K. That's what my instructions kind of hinted me to do. For the times, I'm going to put a times sign. And then, so I've got the W down, I have the equals down, I have the sum number, I have the times down. And then what has to come after the sum number is something that represents the square of x. And square implies an exponent of 2. So I'm going to put an x with an exponent of 2. This equation, W equals k times x squared, is a symbolic representation of W equals some number times the square of x. This is correct. This is a correct variation model. It would be better if I didn't have the times sign between the k and the x squared. I wrote the times sign there because I saw the word times, but if I wrote the k and the x squared next to each other, it would mean times anyways. So both of these would be correct answers for problem 1. That's an equation that has the same meaning as the initial statement. I used k for the letter that I had to introduce, and there isn't any more to do than that. For each of the first 8 problems, it might actually turn out to be more than 8 problems. Might have to tweak that, but that might not be the right number. But anyways, for each of the first 8 or more problems, I'm just going to take the initial statement, create an equation, and stop. There isn't any algebra to do other than creating an equation because there aren't any numbers in the problem. So theoretically, you should be able to do problem 2 because it's similar. It has the same words in it that are important. So just like I did for problem 1, I look at the original problem. It says a varies directly as the square root of b. I'm going to change the word varies directly, and I change the word varies directly as equals some number times. So I took the initial statement. My goal is to translate the statement into words. The way the statement is written for me, it makes it hard for me to translate the statements into words. I took the word varies directly, and because I know varies directly relates to multiplication, I dumped out the word varies directly, put in something that's equivalent to varies directly. Now I'm going to create my equation, and the first thing I'm going to do, it says a equals, so I'm going to take the letter a from the problem. For the equal sign, I'm just going to put an equal sign. For the sum number, I'm going to put the letter k. For the times, I'm going to put a times sign. And then after the times sign, I need the square root of b. So there's a difference between square and square root. In problem 1, after the k, I needed a square of x, and I put an exponent of 2. In problem 2, I need the square root, and a square root is a radical symbol. So after the k, I'm going to put a b under a square root symbol. This would be a correct answer. Just like in the last problem, a better answer wouldn't have the times sign between the k and the square root of b, because the times would be implied anyways. So that would be the best answer for this particular problem. So square means exponent, square root means radical. It could happen that we might see cube. If I see a cube, that word would mean an exponent of 3. And if I see cube root, it's going to be a cube root symbol. I don't think I see cube root in this section, but we might see cube. So root implies radical symbols. The words square and cube without the word root implies exponents. That's going to be important as we get further. So 3 is another problem that I'm going to take the statement. I'm going to rewrite the statement with words that I understand. So immediately I go to this problem. I see the word varies inversely. I change the word varies inversely to equal some number divided by. And now I'm going to write my equation. In this paragraph that I skipped over, it says what's commonly done algebraically when you have the word varies inversely. What's commonly done when I have the word varies inversely, because divided could be represented several ways, what's commonly done for varies inversely is that I create a fraction and the k is in the numerator. So because this is a varies inversely and I need a divided, one way to show a division is with a fraction. That's the way I'm going to show it here. So I'm going to write my equation down. For the letter y, I'm going to leave it a y. For the equals word, I'm going to write equals. And then for the sum number, I'm going to put a k. And for the divided, I'm going to create a fraction. Because the letter k is before the fraction, or the word that implies fraction, the k goes in the numerator. And then the last thing I need is the cube of x. Because it's after the word divide, after the word that implies the fraction, it goes in the denominator of the fraction. And the cube of x is going to be an x with a exponent of 3. Problem 4 should have the same skill set as problem 3. So hopefully you can pause the video, do problem 4, and then watch my video and check yourself. So hopefully you've paused the video, done problem 4, and hopefully you did exactly what I did here. You took the initial problem. You notice it had the word varies inversely as. You changed the words varies inversely as to is some number divided by. And then you started constructing your equation. The letter z is going to remain the letter z. The word equals is going to turn to an equal sign. The word some number is going to turn to the letter k. The divided by is going to give me a fraction. Because the k is to the left of the divided by, it goes in the numerator of the fraction. And then after the is divided by, I see the square of y. That's going to go in the denominator because it's after the words that imply fraction. And I get an exponent as opposed to a radical sign. I don't see the word root, so I get an exponent of 2 because a square implies an exponent of 2. And that's all there is to do for number 4. 5 is odd because it has 2 of the words combined into one problem. As I read this problem, it says q is directly proportional to the square of x and inversely proportional to the cube of y. It feels like I need 2 k's, 1 k for the directly proportional, 1 k for the inversely proportional. My goal is to somehow simulate this make it an equation out of this statement that only has 1 k. So in this little blurb, I said I want to translate these words into symbols. I will treat directly as proportional just like varies directly as, and inversely proportional as, and varies inversely as. I want to create an equation with 1 k to do this problem. And then I took the initial sentence and made a rewrite. And very specifically, I wrote q and then equals some number times. This part right here is for the directly. And then I did and some number divided by, and that's for the varies inversely. So I translated the initial problem into a problem that had words that I understand better. Directly proportional, I made equals some number times. Inversely proportional, I made it some number divided by. Now it's going to be a little bit tougher to get my equation. You almost just have to see this. And after you see a couple of them, then maybe you can do it. But it's not intuitive. I would guess if I was a student, I wouldn't come up with the answer that I want just by myself. So for the letter Q, I'm going to write a Q. For the equals, I'm going to write an equals. For the some number times, I'm going to write a K times. And what it's going to be times is the square of x. So if I just went to here and stopped right there, I'd get that. Notice I didn't write the kx squared on the same level as the equal sign because I'm also going to do the sum number divided by. And I'm going to show the sum number divided by having a fraction with a k in the numerator. Because the k came before the word some number divided by, it needed to be in the numerator. The thing that needs to go in the denominator is the cube of y, because those are the words after divided by. And this is the correct translation with 1k of the statement in problem 5 into an equation. So q equals to kx squared in the numerator. That's the directly proportional. I can see the directly proportional to the square of x. if I just don't look at the y cubed. I can see the directly proportional part. And if I don't look at the x squared, I can see the inversely k over y cubed. So that would be how that one is supposed to be attacked in terms of how to get an answer when you have both directly and inversely in one problem when you want to do it with 1k. 6 is the same sort of problem as 5. So again, it would be nice if you pause the video, solved problem 6, and then checked yourself. And you know, these problems should go quickly. If you have the answer to 5 staring at you, I'm going to do this exactly the same way. The words are almost identical, other than I might have thrown a root in the problem rather than a square. But other than that, it's not that big of a deal. It's not that different, should I say. And notice I used the word is as opposed to equals when I rewrote this problem. And mathematically, is and equals are often interchangeable. So when I rewrote this problem, I took the word is directly proportional to, and I wrote is some number times. I could have wrote equal some number times. And I took the word inversely proportional and write the division statement. So now I'm going to take my problem, the W, I'm going to write as a W. The is, I'm going to make my equals. The sum number, I'm going to make a K. For the times, I don't need a times sign, so I'm not going to write a times sign. After the K, or after the times sign that I might have write, I'm going to write the square root of x, and the square root of x has an x under a radical symbol. And then I have the divided by, and then after the divided by statement, I just see the letter y without any words that imply it needs a radical or an exponent. So there would be the answer that number 6 is looking for. W equals k times the square root of x over y would be the perfect answer for number 6. I think 7 and 8 are jointly problems. And for jointly, I'm going to have two numbers or two letters multiplied after the k. Jointly and directly are real similar in that they're after the k you have multiplication, and directly you only have one letter after the k, and in jointly I'm going to have two letters after the k. So immediately I looked at the problem, saw the word varies and jointly, and I knew that varies and jointly is still some number times, but it's instead of having one letter after the k, I need two. So now I took my sentence, changed it a bit, and now I'm going to write my equation. The letter m, I'm going to leave the letter m. The equals, I'm going to write as an equal sign. The k, I'm going to make some number. After the k, I need two letters. And very specifically, the two letters I'm going to need are the square of x. Don't see a root, so I don't need a radical. I need an exponent. And the cube of y. I don't see the word root, so the cube becomes an exponent of 3. Don't really need the times symbol because having the k, the x squared, and the y cubed next to each other implies multiplication. So jointly is not really that different than directly. It's straight multiplication, but you have two letters after the k as opposed to one letter after the k. All right, same deal here. You should be able to pause the video, solve problem 8, because it works just like number 7. And then you can check yourself. So hopefully you did that. When I do problem 8, same deal. I see varies jointly. When I see the word varies jointly, I know I need equal some number times, and it's a multiplication problem. But after my k, there's going to be two letters as opposed to one letter. So I took the initial problem, wrote it as something that I understood better to make an equation. The first letter in the problem is B. The word equals, I'm going to make an equal sign. The sum number, I'm going to write as a k. Because it's jointly, I need two letters after the k. The first letter is just going to be x without any radicals or exponents, because there isn't any word directly attached to the x that implies I need an exponent or a radical. And then to the left of the y, I see the word square root, so the y needs to be under the square root symbol. So the correct translation for number 8 would be b equals to k times x times the square root of y. That would be rewriting the statement into symbols, and that's what was my goal. I think there's more writing the statements as symbols. Oh, yes, there is. And these are a little more abstract. These are, the next few problems are to prepare us for some of the more complicated word problems in the problem, in the section, should I say. So as I read problem 9 says the distance d an object falls is directly proportional to the square of the time it falls. This, I'm supposed to be able to take this statement and make an equation. I did the same thing. I took the statement and wrote it in better words. I wrote the distance d an object falls is equal to some number times the square of the time that it falls. So immediately, when I see varies directly or is directly proportional to, I know I need an equation with a k. I have one letter to the left of the equal sign, then an equal sign, and then one letter after the k. The first letter in the problem represents the distance, and that's going to be the letter that goes to the left of the equal sign. So this part right here, up to this just gives me the d that goes in the left of the equal sign. And then I use the word equals, so I put the equal sign, and this should probably say some number times. For the sum number, I'm going to put my k. And then for the times, I'm not going to put a times symbol because when I write something right next to the k, it's going to imply times. And what I write after the k needs to represent the square of the time that it falls. I told you to use t for the time, and I want the square of the time. I'm going to write t squared for that. So the equation that represents number 9 in symbols is d equals to k times t squared. It was directly proportional, so I know I needed multiplication. The first letter that I see in the problem goes to the left of the equal sign. After the k, I needed something that represented the square of the time. Squaring, and time was t, and squaring it gives me an exponent of 2. 10 should be similar to number 9, but it might be a little bit different. It would be good if you can do 10 without my help and then watch me do it. But if you can't and just watch me do these, this is okay. So as I read through 10, I see the word varies directly again. Immediately when I see the word varies directly and I'm asked to write an equation, I know I'm going to have a letter to the left of an equal sign and then a k, and only one letter after the k. And the words are going to tell me whether I need an exponent or a radical sign or what I need to the right of the equal sign. So I rewrote the problem with the word some number times replaced by directly. I didn't write the word equals, I wrote the word is, but up to here, the monthly payment P on a mortgage, that's the P that goes to the left of the equal sign. The word is gives me the equal sign. The sum number times gives me the k and a times symbol that I don't need to write. And then after the k, the letter I need is something to represent the amount borrowed b. And after the word times, I don't see anything that talks about squares, square roots, cubes, or cube root. So the next letter of b that I see, it doesn't need an exponent. It just needs to go there. So because it varies directly, I know that the first letter that I see is going to go to the left of the equal sign. The second letter I see is going to go after the k, and the problem itself will tell me whether that letter that goes after the k needs an exponent or a radical. In this case, it didn't need any of those. So you hopefully are starting to get a little bit of independence, and you might be able to do problem 11 without my holding your hand or doing it first. So if you pause the video, write down an answer and check yourself. That's the very best thing you could do. If you don't feel comfortable yet, I'll still do the problem and you can watch me do it. But ultimately, you need to be able to do these things by yourself. And so watching me, at some point, you just have to stop watching me and just do it yourself. So immediately as I look through this problem, I see the word varies inversely. And once I see the word varies inversely, I know I'm going to form a fraction with a k in the numerator. I know the letter that's going to go to the left of the equal sign, and I know the letter that's going to go in the denominator. It's just a matter of I need any exponents or radical signs. So I rewrote the problem. I said the maximum weight that can be supported by a 2x4. So this whole bit right here is up to the word is, gives me the w to the left of the equal sign. This word is gives me the equal sign. The sum number divided by, because it varies inversely, I need a fraction with a k in the numerator. So the sum number divided by, or the varies inversely, gives me a fraction with a k in the numerator. And then after the word divided by, I see its length. And I don't see any words that tell me I need an exponent or a radical. So I'm just going to put an L down low, and I get W equals K over L. And that's the equation that relates the words, that's equal to the words in problem 11. So 12 and 13 are still this style of problem where all I'm doing is creating an equation. 12 is similar to 11. The words are completely different for the most part, but I see the word inversely in it. And as soon as I see the word inversely in it, I know I'm going to form a fraction and that there's going to be a k in the numerator of that fraction. I rewrote the problem, but at some point you might get to the point where you can just do the problem, write the equation without doing a rewrite. So up to the word is, that gives me the d that goes to the left of the equal sign. The word is gives me the equal sign. The inversely related gives me a fraction with a k in the numerator. The letter that comes after the inversely is the letter that goes in the denominator. And here it says it's inversely related to the price. And again, I don't see any words after the inversely that tell me that I need an exponent or a radical. I don't see root or a square or a cube root, a cube word. So I'm just going to put a p in the denominator. And that's the equation that problem 12 wants. (13) and 14 are still this style of problem where I need to create an equation from the problem that's given. They're more complicated than the first 8 problems because they're more word problem-like. When I read through problem 13, I see both varies directly and varies inversely, although I didn't write the word varies, but I see directly and inversely, which is supposed to relate to one of the problems we did earlier. Hopefully you can come up with an equation that maps this out perfectly. As I go through the problem, up to the word varies directly, this part right here is going to give me the V equals. And when I rewrote the problem, I wrote this as the volume of an enclosed gas is, the volume gives me the V, the is gives me the equals, and then I know because I see varies directly, I'm going to need a k times something, and what comes after the words varies directly tells me what I need to multiply k by, and it varies directly as the temperature, so after the k, I need a t for the temperature. I don't need an exponent because there isn't any words like squared or square root, and then I see inversely. Inversely, I need a fraction with a k in the numerator. And then after the word inversely, I need something to represent the pressure, which is the letter P. And again, I don't see any words after the words inversely that tells me that P would need an exponent or a radical. So writing V equals KT over P is the best I can do in terms of writing 13 as an equation. 14 is the last one of the problems where there's no numbers. There's just taking the statements and making an equation. As I read through problem 14, the only varies that I see is varies directly. When I see varies directly, I know I'm going to have one letter, an equals, and a k, and then after the k, I'm going to have something I'm multiplying by. So to the left of the equal sign, what I need is the diameter of the largest particle that could be moved. To the left of the equal sign, I'm going to write a D. And then once I get to the word varies directly, I'm going to get my equal sign and my K. Varies directly I know is multiplication. So I'm going to write a K, and then after the K, I'm going to write something that represents the words after the word varies directly. And after the words varies directly, it says the square of the velocity. Tells me the letter to use for velocity. I only need one letter after the K. It's going to be a V. But also I have got words to tell me that the V needs an exponent, and the exponent's going to be a 2. And that's the equation that I need for number 14. If you can create the equations, you can do the rest of the section no problem. We're through the hard part of the section. The rest of the problems, they have some numbers in them, so I'm going to pull out my calculator, but they won't be hopefully too challenging. So that group of problems up through 14 were the challenging problems. 15 through 20, the instructions say find the constant of variation K, and these problems are two-step problems. So what I'm going to do for each of the problems between 15 and 20 is I'm first going to create an equation with a K, just like I did in the first 14 problems. And then, second, I'm going to plug in the given numbers and solve for K. My answer to this problem is just going to be whatever K equals. My answer is going to be K equal to whatever it equals to. The equation that I'm using to find out K, that's not the most important thing. The answer is the K itself. So what I'm going to do for problem 15 is look at that portion of the statement first that says y varies directly as the square of x. And from that, I'm going to create an equation with a K. I know that to the left of the equal sign when I create my equation, I'm going to get a y. I'm going to have an equal sign. Because I see the word varies directly, I know it's just one K followed by one letter, and it's a times. It's no divide. So I'm going to write a K. And then after the K, I need the square of x, and the square gives me an exponent. So that's the beginnings of this. I've created an equation with a K. Second, I'm going to plug in the given numbers and solve for K. The given numbers are y is 45 when x is 3. So I'm going to go 45 equals K. And I'm going to put the 3 in a parentheses because of the exponent. Now I'm just going to do just simple algebra to solve this for K. First thing I'm going to do is the exponent. 3 squared is 3 times 3 is 9. And I can write 45 equals K times 9, or I can write 45 equals 9K. They're both equivalently correct. To finish this up, to divide both sides by 9, I'll get K. And then 45 divided by 9 is 5. The answer to problem 15 is just going to be K equals to 5. So all the initial equation, the numbers that I plug in, are all just there to get me to the final goal, to write K equal to some number. So for this particular set of words and numbers, K is 5. 16 is going to work the same way, so hopefully you can do 16 without me. And then check your work. So in 16, the first thing I'm going to do is create an equation with a K. And then I'm going to take the numbers that are given in the problem and solve for K. My answer is going to be K equal to some number. So again, in 16, I see it varies directly, which is kind of my favorite because it's straight multiplication. I only need one letter after the K. The first letter I see in the problem is M, so I'm going to write an M. After the M, I'm going to write an equal sign with a K. Don't need a fraction because I don't see varies directly. After the K, I only need one letter because I don't see the word jointly. And I see root, so the y needs to be under the radical symbol. So the equation that the first part of this statement it can be changed to as m equals k times the square root of y. Now I'm going to plug in 12 for m and 16 for y. I can do the square root of y, 16 in my head, that's 4. I'm going to rewrite this as 12 equals 4k rather than writing k times 4, which would look kind of odd. Divide both sides by 4. On the left side, when I divide by 4, I get 12 over 4, which is 3. On the right side, the 4's cancel, and I get k. The answer to this problem, what's asked for, is the value of k that fits the problem, and the answer is k equal to 3. Same deal with 17, so hopefully you can do 17 independent of me. First thing I'm going to do is create an equation. And then I'm going to plug numbers into the equation. If you're working ahead, a slick way to solve varies inversely algebraically is cross-multiplying. If you work ahead and get the right answer for k, and you do something different than I do algebraically, then don't worry about the way I do it. There's multiple ways to do the algebra. I'm going to do cross-multiplying because students generally do cross-multiplying well. So, first thing I do is create an equation with a k. The first letter I see is t. I write a t, then an equal sign. I see varies inversely, so I know I need a fraction with a k in the numerator. After the word varies inversely, I see the letter q, and there aren't any words like square, square root, cube, or cube root to tell me I need anything but the letter q. So that's the equation. Now I'm going to plug the numbers in. I'm going to plug in 10 for t and 5 for q. If you wrote 2 for your answer, then you fell into the trap of just dividing when that's not correct. If you wrote 50 for the answer, then you did whatever you did was correct. What I'm going to do is set this up to cross-multiply because students generally cross-multiply real nicely. So I wrote both sides as a fraction. I'm going to cross-multiply up and cross-multiply down. When I cross-multiply up, I get 1 times k. When I cross-multiply down, I get 10 times 5. For 1 times k, I'm just going to write k. For 10 times 5, I'm going to write 50. So the answer that I'd want for problem 17 is just the number 50. '18 is very similar to 17, so hopefully you pause the video, work it, check yourself. The answer for these varies inversely are often a lot bigger number than you think. So if you did this problem and got 5, you probably fell into the trap that was set for you. First thing I do is I look at this problem, want to create an equation with a k. Because I see the word varies inversely, I know I need a fraction with a k in the numerator. Z came first in the problem, so I wrote it first. After the word z, I see the letter x. There isn't anything that tells me the x needs an exponent or a radical, so I'm just going to put the letter x. Plug the numbers into the problem. 4 for z, 20 for x. My answer is going to be a number for k. Like to solve inversely by cross-multiplying. If I'm going to solve by cross-multiplying, I need both sides to be written as a fraction. I can write the 4 as a fraction by writing it as 4 over 1. I'm going to cross-multiply down, cross-multiply up. When I do that, I get 4 times 20 equals 1 times k. That's going to give me 80 equals k. And it doesn't matter what side of the equal sign the k is on. So k equal to 80 or 80 equal to k are both correct answers. Ultimately, if this was a test, I'd be just looking for the number 80 anyways. 19 and 20 are similar problems in that I need to come up with an equation with a k. I need to take the numbers that are in the problem, plug them in and solve for k. My answer is going to be k equal to some number. When I read problem 19, I see the word varies jointly, so I know to the right of the equal sign I need the letter k, and then 2 letters after the k, and I don't get any dividing because I only get dividing when I see inversely. So the equation for number 19 is going to be n equals, I always get my k, and then after the k, the letters, I need 2 letters because it's jointly, are going to be x and y, and neither the x nor the y need exponents because there aren't any words that tell me I need exponents. So that's the equation that's necessary. Now I'm going to plug 42 in for n. I'm going to leave the k alone. I'm going to plug in 2 for x and 3 for y. I can put the 2 and the 3 in parentheses. I put time signs because it's k times x times y. Parentheses and time signs both could represent times. I'm going to simplify the right-hand side by multiplying the 2 and the 3. That's going to give me 6. So that gives me 42 equals to 6k. I divide both sides by 6. 42 divided by 6 is 7. And the answer that I'd write for problem 19, if this was a test question, is just k equal to 7. The equation that I needed to get the k equal to 7, you wouldn't write on an answer blank, but if you didn't have that equation right, you probably wouldn't get the right answer. 20 is the last, what I would call a two-step problem, in that I come up with an equation, and I shove some numbers in to get my answer. My answer is a value for k. So I read up until the numbers in problem 20. The first letter I see is n. I write an n then an equal sign. If I don't see the word inversely, then I know I don't need a fraction, so I don't need a fraction. I see the word jointly, so after the k, I know I need to have 2 letters. And the letters are going to be y and x. The y doesn't have any need to have an exponent or a radical symbol because there aren't any words that imply that. But the x does. The x needs an exponent of 2 because of the word square that's written right to the left of the x. So the equation that's appropriate for number 20 is n equals k times y times x squared. Plug the numbers in, plugging 54 for n, leaving k alone, plugging 2 for y, plugging 3 for x. Notice this time I used parentheses instead of time signs. Those are interchangeable. They both mean times. Orders of operations. I need to do the exponent before I do the multiplication. So to the right of the equal sign, if you got a 36 there temporarily because you did 2 times 3 is 6 and 6 squared is 36, you violated the orders of operations. You do exponents and then multiplication. So the correct algebra would have 54 equal to 18k, and then you divide both sides by 18, and the answer to this is going to be 3 equal to k. The rest of the problems from 21 on are all going to be 3-step problems, and when I wrote the problems on my typed sheet, I broke the problems up so you could see the steps. Each of the problems from 21 on is either written with 3 sentences or kind of has 3 steps to it. And it looks like that all the problems between 21 and 34 actually had 3 physical sentences. So when you looked at 21 in your handout, you wouldn't be broken up like this. But the problems between 21 and 34 all need to be thought of as 3 separate problems. So very specifically, these problems between 21 and 34 are 3 steps. Step 1 is to create an equation with a k. Step 2 is take the numbers in the middle sentence and solve for k. Step 3 is to take the numbers in the last sentence and answer the question. The last step is the question that needs to be answered. For this particular problem 21, the question that needs to be answered is I need to find y when x is 5. But in order to get answering this question, which is the ultimate question, I need to do some steps. The first step I'm going to do is I write an equation with a k. I see the letter y. I'm going to write a y, then an equal sign. Varies directly. I know it's a multiplication. And after the k, I only need 1 letter. There's no fraction because I don't see the word inversely. For the cube of x, I'm going to write an x with an exponent of 3. So that's the first sentence translated into an equation. Second sentence in the problem gives me some numbers. I get 24 equals k times 2 cubed. I'm going to do the exponent. 2 cubed is 2 times 2 times 2, which is 8. So this gives me 24 equals 8k. Now I'm going to divide both sides by 8. And in the second step, I get 3 equal to k. Still not done with the problem. I've created an equation. The equation was y equals kx cubed. And now I want to answer the question, find y when x is 5. To find y when x is 5, I'm going to plug 3 in for k, because for this problem, k is always 3. And I'm going to plug in 5 for x. And I put a time sign. I could have put a parentheses for the times. Orders of operations want me to do exponents first. If you did 3 times 5 and did 15 and then cubed it, you'd be wrong. I'm going to do 5 cubed. 5 cubed is 125. And then I'm going to multiply by 3. The answer to this question is just the single number. Since I'm finding y, I'm going to write y equals. And what that equals to, I can do without a calculator, is 375. But you should use your calculator if you can't do that in your head. So every problem between 21 and 34 is exactly what I'm going to do. I'm going to take the initial problem. I'm going to break it up into 3 segments. The first segment is going to allow me to get an equation for a k. The second segment is going to allow me to solve for k. The third segment is going to be the question that needs to be answered, and I'm going to plug the numbers in to the equation and answer the question. So when you feel independent, try to do through these by yourself and then check. So hopefully you pause the video when you start to feel comfortable and work as many problems as you can, and then start checking yourself. So 22, first sentence, z varies directly. I know that varies directly gives me a multiplication. After the multiplication of a k, I need the square of x. That's an exponent of 2. So the first sentence that I broke away from the other 2 sentences gives me the equation z equals kx squared. Second sentence says z is 54 when x is 3. So I get 54 equals k times 3 squared. 3 squared is 9, so I get 54 is 9k. Divide both sides by 9. And the second sentence leads me to k equal to 6. Now I'm going to answer the question. It says find z when x equals -2. So into the equation, I'm going to plug in a 6 for k, because for this problem, k is always 6. And I'm going to plug in a -2 for x, because I'm asked to plug in -2 for x. Do exponents first. -2 squared means -2 times -2, which is +4. So this is going to be z equals 6 times 4. The answer to this question is the z. When x is -2, the answer is going to be 24. So I'll go through these kind of quickly with the hopes that you're just checking and not doing these with me. So hopefully you've paused the video and you're working through almost all of these problems. I think you might be able to do all of them without me. 23, first sentence, I broke from the other 2. I see the word varies inversely. Varies inversely, I know I need a fraction with a k in the numerator. The first letter I see is w. It goes to the left of the equal sign. Under the denominator, I need something to represent the q. I don't get an exponent because I don't see any words like square or square root or cube with the q. I'm going to solve this by cross multiplying here in a second. I'm going to plug it from the second sentence, 10 in for w, 5 in for q. I'm going to set this up to cross multiply. I'm going to write the 10 as 10 over 1, cross multiply down and up. That gives me 1 times k equals 10 times 5. So the second sentence leads me to k equal to 50. Now I'm going to take the equation that I came up with, w equals k over q, and I'm going to solve. I'm going to get an answer, w equals, I'm going to plug in 50 for k and 3 for q. I'm going to get w equals 50 over 3, and that is a decimal. And because the initial problem doesn't have decimals, I probably wouldn't write a decimal answer. I'd leave my answer like that. Or if you want to, oh gosh, this is 16 2/3 equal to w. both of those would be okay. But an improper fraction, I prefer to a mixed fraction usually. So 50 over 3 would be a perfect answer for 23. So again, all these problems, when I typed up my sheets, I made room for each of these steps. Took each sentence, made its own room for it. So first sentence, I write an equation with a k. Because I see the word varies inversely, I know I need a fraction with a k in the numerator. In the denominator of the fraction, I need the square root of n. So I put the n under a radical symbol. Now I'm going to solve for k. I'm going to cross multiply in a second. I'm going to plug 15 in for m and 9 in for k, or for n, should I say. The square root of 9 is 3, so I'm going to get 15 equals k over 3. I'm going to write the 15 as a fraction so I can cross multiply. I'm going to write 15 over 1 equals k over 3. When I cross multiply, I'm going to get 1 times k equals 3 times 15. So k is going to be 45. Now I'm ready for my third sentence. My third sentence, I'm going to use that equation, m equals k over the square root of n. I'm going to plug in 45 for the k and 16 for the n. I'm going to get m equals 45 over the square root of 16. I'm going to rewrite the square root of 16 as 4. So I'm going to get m equals 45 over 4. That turns into a decimal. You could write m equals 11 and 1/4 if you care to, but 45 over 4 is just fine. 25, still in the same style of problem. I broke this problem up into 3 sentences. First sentence, I get my equation with a k. I see the word varies jointly. I know it's straight multiplication, no division. After the k, I need to have 2 letters as opposed to 1 letter. So I'm going to write y equals k, and then x doesn't get an exponent or a radical sign, but the z gets an exponent of 2 because of the word square without the root. Second sentence, I plug in 48 for y, leave the k alone, plug in 3 for x, put in 2 for z, so I get 48 equals k times 3 times 2 squared. Do exponents first. This is going to give me 48 equals k times 3 times 4. That's going to give me 48 equals to 12k. And when I divide both sides by 12, I get 4 equal to k. Go to the third sentence, use my equation y equals k times x times z squared. In for k, I'm going to plug 4. In for x, I'm going to plug 3. In for z, I'm going to plug 4. So I get y equals 4 times 3 times 4 squared. Orders of operations has me do exponents first, so this is going to be 4 times 3 times 16. 64 times 3, I think that's 192. I'm going to pull out my calculator because there's a chance that I messed up there. So 4 times 3 times 16 is 192. So nothing different in problem 25. 26, still nothing different. In fact, none of the problems are different other than maybe this very first sentence might get more complex. But they're all complexities that we've seen, so hopefully you're doing well here. So I broke 26 up into the 3 sentences. First sentence, I see the word varies jointly. When I see varies jointly, I know I need no division, because I only get division when I see inversely. But after the k, I need 2 letters as opposed to 1. The letters are going to be a, and then the c is going to be under a radical symbol. So I'm going to get an a, and then a c under the square root symbol. Second sentence, I plug in 60 for b. I leave the k alone. I plug in 5 for a, and I plug in 9 for c. I need to do the radical before the multiplication. The square root of 9 is 3, so I'm going to get 60 equals k times 5 times 3. Multiply the 5 and 3 and get 15. So I get 60 equals to 15k, and then divide by 15, divide by 15. That gives me 4 equals to k. Last sentence, I use my initial equation, b equals k times a times the square root of c. I'm solving for b. For k, I'm going to plug in 4. For a, I'm going to plug in 4. For c, I'm going to plug in 16. So I get b equals to k, which is 4, times a, which is 4, times the square root of c, which is the square root of 16. This is going to be b equals 4 times 4 times 4, which is 64. So the answer to problem 26 is just going to be b equal to 64. The next few problems are slightly more complicated, but they're all things that we've seen. I intentionally put the complicated stuff in at the beginning so that when we got to this section, it might go a little bit easier for you. So 27 also has 3 sentences. And when I wrote this up, I just hit some space to make room for my 3 sentences. So the first sentence, I need to come up with an equation with a k. And immediately, I see the word inversely. We've already actually done this. This is an earlier problem that we've done in the, the 12 to 15 range. So I'm going to come up with an equation. I see the letters d and p. And inversely, the d is the first letter I see, so I'm going to write a d equals. I see the word inversely, so I need a fraction with a k in the numerator. In the denominator, I'm going to get a p, and I look to the left of the word price p, and I don't see anything about squares or square roots. So that's the equation that the first sentence gives me. I know I'm going to solve by cross multiplying. I didn't leave myself a lot of room here. But what I have is 2 numbers to plug into this. The 275 is the price per bag. I'm going to put that in for P. And the 156 is the demand. It's the number of bags that I'm selling. So I'm going to take 156 and write it equal to K over 2.75. Numbers are getting out of control, so I'm going to use my calculator. I'm going to solve for K by cross multiplying. I'm going to write it as 156 over 1. I'm going to cross multiply up and get 1 times K. And cross multiply down. So I'm going to get 1 times k equals to 156 times 2.75. Completely calculator worthy at this point. So 156 times 2.75 equals to 429. So I get k for this problem is 429. Done with the second sentence, ready to move down to the third sentence. In the third sentence, I'm going to use the equation d equals k over p. And in for k, I'm going to plug 429. In for p, which is the price, I'm going to plug $3. So I'm going to say the demand, the number of candy, whatever I'm going to sell, bags of candy, is going to be 429 divided by 3. And I'll round this if it doesn't come out perfectly, but it did come out perfectly. So the demand, how much candy I'm going to sell, I'm assuming this is bags of candy, is going to be 143 bags of candy. So, and the other problems that didn't really have as much verbiage, my answer I didn't attach words to, but in this case, each of the letters had things that they, physical quantities that they represented, so I wrote my answer a little bit nicer. And it's not a sentence or anything, but it's a better answer. So you might be able to do 28 because it's exactly the same problem with different numbers. So take a second and try to do 28, pause the video, and then watch my solution. So the initial equation is going to be exactly the same. The first sentence for problem 28 is exactly that for 27. So my equation is just going to be d equals k over p. Second sentence helps me solve for k. I'm going to plug in 150 for the D because that's the number of bags, that's the demand. K I don't know. I'm going to put in 4 for the P. Solve this by cross multiplying. I'm going to write 150 as 150 over 1, and I'm going to cross multiply, which is going to give me 1 times K equals 150 times 4. Don't really need the decimals there. And 150 times 4 is going to be 600. So I'm going to get K equals to 600. Done with the second sentence. Moving on to the third sentence. In the third sentence, I'm going to use the equation D equals K over P. And for K, I'm going to plug 600. And for P, I'm going to put the price of the candy because that's the price that's given. I'm going to get D equals to 600 over 5. I don't really need the decimals, but it's okay to have it. I'm going to use my calculator. I think I'll get 120 here, but let me do this. 600 divided by 5.00, and I get 120. So the demand is going to be 120 bags of candy. So as the price went up, the demand goes down. The answer is the 120, and because the 120 represents how much candy I'm going to sell, it'd be nice if I put that on there in my answer. 29 is a messy problem because it has two words in the first statement. It has varies directly and it varies inversely. We did this problem already, this portion of this problem, without the bottom two statements. In order to do problem 29, I'm going to come up with an equation. The letter that goes to the left of the equal sign represents the volume of an enclosed gas, and I'm not a physicist, so this doesn't mean a lot to me, but I can still do the problem even if I don't understand the physics behind the problem. So I'm going to write V equals, to the right of the equal sign, I need varies directly as the temperature, so I'm going to write K times T for that, and inversely I get a fraction, and inversely as the pressure, and the word after the inversely gives me the denominator of the fraction, and it's just the pressure. So that's the equation that I need. We came up with that equation earlier, so it's a repeat. Now I'm going to plug these numbers in. This is going to be a mess to solve. So the pressure, which is P, so I'm going to plug in point, this right here is going to be my P, it's the pressure. I'm not going to worry about units. This temperature must be in Kelvin. And the V is the volume. I don't have a lot of room here, so I'm going to write it up here. I'm going to plug in 8,000 for the volume. I'm going to leave the K alone. In for the temperature next to the K, I'm going to put times 294. And then in for the pressure, I'm going to put 0.75. I'm going to use my calculator a bunch on this, and I might get stuck with a decimal answer. First thing I'm going to do is do this division, 294 divided by 0.75, and write that number next to the K. So I'm going to go 294 divided by 0.75, and I get 392. So this problem could be written now as 8,000 equals 392K. Now I'm going to divide both sides by 392. Hopefully it comes out to a nice number. If it doesn't come out to a nice number, I didn't say how far to round. I'm going to round my K to 2 decimal places. If I was intelligent, I would have told you how to round it, but I didn't. So because I didn't, I'll just default and round to 2 decimal places. Maybe I'll write that in a little bit here. So I'm going to write K equal 20.41 because it comes out to 20.408. And this 8 can round that 0 up to a 1. So for this, I'm going to say K equals 20.41. If you use a different version of K than I use, your rounding is different, your answer is going to be different. So now I'm going to answer the question. I'm using the formula volume equals K times temperature over pressure. In for the K, I'm going to put 20.41. So I'm going to get V equals 20.41. And then in for the temperature, I'm going to put 300 Kelvin, I guess. So I'm not using units. I'm not a chemistry teacher, or a physics teacher, which they might really dislike this, but I'm dealing with no units here. And then the pressure is 1.5. So I'm putting these numbers in, and I'm going to do this all on my calculator. I'm going to go 20.41 times 300 divided by 1.5. And I get 4,082. So the volume is 4,082. Just because I didn't do any units in my algebra, it doesn't mean my answer shouldn't have units. And it says the volume is, and if I look at this, the volume's in cubic centimeters here. So I'm going to say 4,082, and I'm going to write cubic centimeters, just because when the volume number was given in the second sentence, the units were cubic centimeters. The units in my answer will be the same as the units in the problem, even though I'm not using units because it would be a real messy problem to do with units that I can safely do. And anytime I'm answering a word problem that's more wordy, that actually has physical names in it, I should probably have units in my answer. 30 should be a duplicate of problem 29. The first statement is exactly the same, so my initial equation is going to be the same. And the second sentence is exactly the same. So for problem 30, the initial statement, V equals KT over P, is because problem 29 and problem 30 have exactly the same words for the first sentence, that part's the same. Because problem 29 and 30 have the exact same words for the second statement, this part is the same. So when I do this, if I did this and wrote 8,000 equals K times 294 over 0.75, I'd still get the same value of K, which is going to be 20.41. The difference between problem 30 and problem 29 is exactly only in the last sentence. In the last sentence, this is where I change the numbers. There's how I'm going to get a different answer. So for the first two steps, I didn't need to do them again. They're exactly the same. I'm going to do the last step. I'm going to write volume equals K, which is 20.41, times the temperature, which is 400 Kelvin, I'm assuming that means, divided by the pressure, which is 2 kilograms per square inch. Do the math and get my answer. So I'm going to go 20.41 times 400 divided by 2, and I get, wow, same 4,082. That, in some sense, surprises me, but I'm not a physicist, so I don't know if that was supposed to happen. But my answer can be 4,082 cubic centimeters. I stole this problem from another book, and I don't know the physics behind the gas law to know if, these numbers make sense to a physicist. But I can do even if I don't understand the physics, I can still do the math. It's not, doesn't preclude me from answering the question. All right, getting to the end of this section. Just a few more problems, and very few, I think. So 31 says the distance a ball rolls down an inclined plane is directly proportional to the square of the time that it rolls. So first sentence, get an equation with a K. The letters I need are D and T. It's directly proportional, so I just need a K after the equal sign. So I'm going to write D for the first letter, the distance the ball rolls, a K because I need a K in all these problems. After the K, I need something to represent the square of the time the ball rolls, and I'm going to write that as T squared. So the equation that I need for 31, since it's directly proportional, I don't need a division. I only need one letter after the K. That letter is going to be T, and I need a square. Now I'm going to solve for K. In 1 second, that's the time. The ball rolls 8 feet. That's the distance. So I'm going to write 8 equals K times 1 squared, plugging in 1 for the time, 8 for the feet. So I have to understand what these letters represent. This is going to give me 8 equals K times 1, because 1 squared is 1. So K is going to be 8. Now I'm going to answer the question, how far will the ball roll in 3 seconds? I'm going to use the formula D equals K T squared. And for K, I'm going to plug in 8, and T is this time, and it's going to be in seconds. So I'm going to go D equals K, which is 8, times 3 squared. Orders of operations, I do the exponent first, so I'm going to do the 3 squared first. I'm going to get D equals 8 times 9, and D equals 72. If I look to the middle sentence, the distance was given in feet, so this must represent feet. So it's going to roll 72 feet down an inclined plane. So the answer I'd write for problem 31 is 72 feet. Eventually the video might just time out on me. So it does, and you might not see every problem that you might want to show you. But it's still going. 32 has the same first sentence and the same second sentence, so the beginning's going to be the same. The equation I need is d equals k times t squared. I plug in 8 for the distance. I plug in 1 for the time. And I get the sum 8 equals k times 1. So k is 8. The only difference between 31 and 32 is the very last sentence. And in this last sentence, I'm going to plug in 6 for the time, 8 for the k. I'm going to use the equation d equals k times t squared. In for k, I'm going to plug 8. In for t, I'm going to plug 6. I'm going to get d equals 8 times 6 squared. 6 squared is 36. Break out my calculator to do the 8 times 36 and get 288. So the distance that the ball is going to roll is 288. And the distance is in feet. So the distance the ball rolls is going to be 288 feet. It's quite a long plane, apparently. 33 and 34, the last two problems in the section. They both have the same initial first two statements. It's only the last statement that's the same. So once I do the first two, it's just the last one I'm going to need to get. So maybe I'll do 33 but not 34 just to save a second here because I know this video is going to be getting close to timing out. So first I'm going to do is come up with an equation. And as I look through this problem, I see varies directly. So I know I need a k and then one letter after the k to the right of the equal sign. To the left of the equal sign, the letter I need is d, which represents the diameter of a particle that could be moved by a stream. After the equal sign, I get a k because of the word varies directly. And then the letter I need after the k is the v, but the v needs an exponent of 2 because of the word square of the velocity. So this equation is supposed to tell me how big of a particle a stream can move. D is the diameter of the particle. V is how fast the stream is moving. Now I'm going to plug in some numbers. I'm going to plug in 1/4 for the velocity. If a stream is moving at a 1/4 mile per hour, which seems pretty slow, I'm going to go, I'll just shove it here. I'm going to write k times 1/4 squared and then equals d, which is 0.02. So the algebra that's going to be done in problem 33 is 0.02 for the diameter equals k times 1/4 squared. 1/4 squared is 1/4 times 1/4, which is 1/16. So I get 0.02 equals k times 1/16. I'm going to multiply both sides by 16. If I multiply the left side by 16, I'll need my calculator. If I multiply the right side by 16, the 16s are going to cancel. I'm going to get k times 1, which is k. So I'm going to get 16 times 0.02 and that's 0.32. It's okay to have a k as a decimal because I have decimals in the problem. So 0.32 is the k for this problem. Now I'm going to use the formula d equals kv squared and answer the question. I'm going to plug in 0.32 for k. And then for the velocity, I'm going to plug 2 miles per hour with a square. Orders of operations, do the exponent first. So I'm going to get d equals 0.32 times 4. And I get 1.28 for d, which stands for the diameter of the product of the particle. And this stream can move a particle that's 1.28 inches in diameter. So the largest particle, this stream, that's flowing faster, 2 miles per hour as opposed to 1/4 mile per hour, is 1.28 inches in diameter. I don't know if I have time for 34. I think I still do. It's got to be like seconds before this thing times out. For 34, the first two parts are exactly the same. The initial equation, because the words are the same, is still d equals kv squared. The middle number, the middle part's exactly the same. The algebra that I did to get the k for 0.32 is still the same. Because The first two statements in problem 34 are exactly the same as those in 33. The algebra is the same. The only difference between 33 and 34 is in the last sentence. And in the last sentence, I have a stream that's faster. A stream that's moving 5 miles per hour can move a bigger particle. I'm going to plug in 0.32 for K, 5 for V, do my operations here, 0.32 times 5 squared, and I get 8. What this formula says, a stream moving 5 miles per hour can move a 8-inch. That's a big, that's not even a particle anymore. I wonder how true that statement is. So it says a stream moving 5 miles per hour can move an 8-inch in diameter particle. That's not even a particle anymore. But I'll believe the equation. And again, maybe this equation, it has some parameters where it only works for certain size particles or certain, but nevertheless, I can answer the question even if the physics behind the question isn't correct because I don't understand, I haven't used the formula to know, if there's some restrictions on when you can and can't use it. So that's everything, every single one of the 34 problems in the section. The word problem section, it's the only word problems that we're responsible for in Chapter 2. So hopefully it wasn't a humbling section. Hopefully as word problem sections went, it's as good as they come. Okay, so all you have to do now is make sure you understand all these sections. Watch the video, complete the review, watch the video for the review. If you can do all the problems on the review video, then you should be perfectly ready for the test from this chapter. Because there will never be anything on a test that isn't just like something on the review.